Um, I am a biologist. I have graduate studies in computer science. And really, I have worked for more than 30 years just as network manager and systems administrator in a research institute at the National University of Mexico, closely following every new technology. And then, when the project of a new degree in neurosciences began to take shape at my institution, they invited me to propose an area of specialization that would integrate the use of new technologies with neuroscience. My proposal to take advantage of the new technologies capable of tracking body movements to develop a new approach to neurorehabilitation was very well received by some researchers who suggested that I start right away a new line of research developing serious games associated with tracking sensors to complement neurorehabilitation therapies. Then that was how we started working in this like 7 years ago. Then I began to visit hospitals and see how was the situation. And I was able to see firsthand the shortcomings of the rehabilitation systems and the patient abandonment. And I was convinced that we were in a position to generate a change for the benefit of patients. So I was very motivated that we could make a change. If I would say that the most difficult thing has been learning to deal with the hospital bureaucracy, with the suspicion of therapists, and with the indifference of many doctors towards the situation of patients with acquired disabilities because of neurological damage. Many doctors are convinced that their job ends once they have prevented the death of patient, and that providing them with the tools to recover their quality of life is not something that falls within their competence. Many times, patients with physical and cognitive disabilities after neurological damage, such as a stroke, are left to fend for themselves with little or no information about their rehabilitation options. The first protocol to test our technology was carried out with chronic stroke hemiparesis patients who have little expectation of regaining movement compared to patients in the very early stages post-stroke, when the best results can be obtained. And our sample size was small because the pandemic went through and we had to suspend the protocol. I really didn't expect to find significant gains in their motor skills, but surprisingly we did, which was very encouraging to me, that this therapy can work even in these chronic patients. Another interesting finding was that when graphing the gains in motor skills at the end of the intervention in relation to the degree of disability they had at the beginning, it perfectly adjusted to a sigmoid curve, which allowed us to identify an inflection point for their recovery. So we found a way to determine recovery expectations from the score obtained through a relatively simple test at the beginning. So we can say from that moment if our intervention will help the patient or not.
The basis of all our work is the neuroplasticity, which is the ability of our nervous system cells to adapt and to change and to generate new communication routes. So this happens all the time when we learn, for example, a new language, or when we learn to play a new instrument, or when we read a book. This capacity is also responsible that we forget things that we don't often practice. But the thing is that this capacity is exacerbated once damage to the brain happens, such as the stroke. And this capacity is exacerbated in the first 3 to 6 months. We have an increase in neuroplasticity in our brain, and it is very important to take advantage of this process to have the best possible recovery in patients. Unfortunately, at least here in Mexico, patients, stroke survivors, rarely receive the therapy that they need with the opportunity and the frequency that they need to in order to get the best possible outcomes. And this is due to a lot of different factors, such as saturation of rehabilitation centers or shortage of specialized therapists, or for example, the socioeconomic situation of the patients, which makes them difficult to transport to the hospitals and to attend their appointments. So we believe that telerehabilitation and more specific, virtual rehabilitation with video games, but more specifically, telerehabilitation is a very powerful tool that we can apply here in Mexico so that the patients can begin with their treatments, with their exercises as soon as possible and get the best possible outcomes. However, we first needed to test that the games that we developed and our sensors were able to be used, were safe and were accessible to the patients. So that was our first step. We began recruiting patients from January to December from 2019 in the National Institute of Neurology and Neurosurgery here in Mexico City. We recruited chronic stroke patients with upper limb paresis, and we made a whole protocol that was evaluated by an ethics committee from the hospital. Then when we recruited the patients, we explained to them what was the intervention about, and they signed a confidential letter. And if they agreed, then we applied some tests. We applied the token test, which allowed us to determine if they were able to follow verbal instructions. Then we apply Fugl-Meyer, which is a very popular test for to evaluate motricity skills. And if this was to evaluate if they have the minimal motricity and abilities needed to play the games. And after that, they attend to the hospital for 20 weeks, twice a week, with an intervention with video games of sessions of 45 minutes. And we applied 2 tests at the beginning of the intervention and at the end, which these tests were CAHI, which is a test more focused on daily living activities, such as opening a jar or dialing 911 or things like that. We also applied a test named Walls Motor Function Test, which is more focused on isolated movements of the shoulder, the hands, fine motricity movements, and it's a little bit longer. And at the end of the intervention, we also administered a survey, a 4-point based Likert survey, and 6 open questions to assess the experience of the patient with the games, if they enjoyed the games, if they felt any pain, if they felt comfortable, if they enjoyed the colors and sound, how was their experience in general, if they were willing to take the games to their home and do their exercises at home. So basically, that was more or less the methodology we made. We also, at the end of the intervention, apply once again these motricity tests to see if there was some motor improvements. Well, from this survey that we did, we found that the games were very attractive and easy to use and safe for the patients, with mobility and from different degrees. We were also able to demonstrate that even in chronic patients, a functional motor gain was observed. And this was very surprising because normally you expect that patients in the subacute stage, that is patients that had a stroke for less than 6 months of evolution, they present very important motor gains. But it is not that common in chronic patients because this stage of augmented neuroplasticity is practically gone. But we found out that even chronic patients using our game, because they weren't receiving any other treatment, only using our game saved some of them. Many of them presented most of our games. That was a very surprising as finding. As Anna mentioned, even we saw that this behavior had like a sigmoid curve. So, well, basically we discovered that games were safe and they were accessible to the patients. And I think that now we are ready to go to our next point in our research.
I have to tell you that in developing countries such as Mexico, there are not many rehabilitation alternatives for patients with motor or cognitive disabilities because of neurological damage. And the appointments at the rehabilitation centers are very reduced. So if we prove that our technology works and we manage to carry out the technology transfer, it will be an accessible option which could help many people to reintegrate into their daily lives. Most people, and I am counting myself before we started working on this, we are unaware of the economic, emotional, and physical burden of caring for a person with a disability. And there are more and more people with some type of disability in the world because of the advances of medicine. Many more people survive these kind of events like a stroke, but they survive with sometimes severe disabilities. And many of them do not have access to traditional rehabilitation schemes and in which a therapist provides personalized attention to the patient. So telerehabilitation with video games is a great alternative to begin to reduce the dependency of some patients and alleviate the burden that it is generated in their environment. So we would like to make a change. We think we are in a good path to achieve this. We already tested our games with the chronic patients. We are now starting a protocol of telerehabilitation in the subacute state. And we are also testing our platform with children with cerebral palsy. So we think that once we have these results, and if they are as good as we expect, we may initiate the process of the technology transfer, trying this technology that we are being very conscious of keep it cheap, available to many people. I will say that this work is very hard. I can imagine that anybody will say that about their work, but in our case, we are a multidisciplinary laboratory. We have programmers, we have electronic, bionic, biomedic, mechatronic engineers, we have graphic designers, industrial designers, psychologists, neuroscientists, therapists, and even music composers. So we have learned that a complete rehabilitation experience can only be achieved by paying attention to all aspects of the development of the sensors and the games to achieve the best multimodal stimulation. I sometimes think that this kind of project is like an amoeba, which is always growing, demanding attention in new aspects of the project. And I feel that it almost have life of its own because it is as if the platform itself were asking for new sensors with better capabilities, better designs, best music, etc. And what you have to do is basically listen to the demands of the project and try to cover them in the best possible way. I will say that it is a complicated job. You must have a lot of patience, mainly for the whole process of working with hospitals, recruiting patients. Be aware that many of them will desert because of many reasons. Um, but in the long term, there is enormous reward when you manage to change life, even for a few people.
Still consider myself a new scholar in this field. I actually don't feel like an expert or anything like that, but based on my few experience, I will say I agree completely with Anna in terms that patience is a key word here. You need to have a lot of patience for all the bureaucratic process and patience also with the patients. It's sometimes difficult to recruit the number of sample that you need for your paper, and you need to be conscious that this is going to be a long work, and as previously mentioned, it's like a whole career ahead of you. I will also say that for the development of games or sensors or technology in general, the best thing to do is to test. I mean, you can have very good ideas in paper and in the laboratory, but always the best is to test everything with the patients, which are your ultimate goal, because it happens to us many times that we were developing the games or the sensors, and we have in our minds a lot of things considered, but once we tested the games or the devices with the patients, something new always came out, and we needed to make adjustments to the games, to make adjustments to the feedback that we're going to give to them, or to the different devices that we developed. So that was also one a very important aspect of all our research. So always test things with patients and have a lot of patience. And yeah, I think that would be the most important things for me.